Most people think the most dangerous part of flying happens up in the sky. Turbulence, storms, engine failures, the idea of being 10 kilometers above the ground with nothing but aluminum between you and physics. That is what feels scary. But aviation has a brutal little secret. Some of the deadliest moments happen when the aircraft is not flying in the way people imagine. They happen on the ground, on taxiways, at runway intersections, in fog, at night, or in the chaos of a busy airport where dozens of moving parts have to align perfectly every minute of every day. Because in the air, you often have one thing that can save you: time. On the runway, you don't. A runway is a narrow strip of pavement designed for aircraft moving at high speed. It is also a shared space. Arrivals, departures, crossing traffic, vehicles, maintenance crews, tow tractors, snowplows, emergency trucks, and sometimes a pilot who is simply lost. That is where runway incursions come in. A runway incursion is any situation where an aircraft, vehicle, or person is in a protected runway area when it should not be. It can be minor and harmless, like a vehicle crossing a runway long before any aircraft arrives. Or it can be the kind of event that becomes a headline, a fireball, and an investigation that rewrites rules for everyone. Most runway incursions end with nothing more than an embarrassed radio call and a report. But the reason the aviation world takes them so seriously is simple. When runway incursions go bad, they go bad instantly. There is no altitude to trade for time, no extra minutes to troubleshoot, no wide open airspace to maneuver into, just pavement and closing speed. And that closing speed can be terrifying. A landing aircraft can touch down at more than 130 knots. A departing aircraft can be accelerating through 150 knots and beyond. Put two aircraft in the same place at the same time, and you have a collision at freeway speeds multiplied by the mass of commercial aviation. Now add fuel. Aircraft on departure are typically heavy, often with significant fuel on board. Tires, brakes, and engines are at maximum stress. If a crash happens, it can create fire quickly, especially if the impact tears open a wing or fuel line. And, because airports are crowded with infrastructure, a runway crash can involve not just two aircraft but buildings, vehicles, and people on the ground. So why does this happen at all? Why does a modern system built on checklists, clearances, and strict procedures still allow runway conflicts? Because airports are complex in a way the average passenger never sees. Picture an airport surface map. It is basically a road system, except the cars are enormous aircraft with limited visibility from the cockpit, slow turning ability, long stopping distances, and constant radio instructions coming in while crews are handling checklists, monitoring traffic, and trying not to miss a single hold line. Add low visibility, and it becomes a maze. In fog, the world shrinks to a tunnel of lights. Taxiway signs can be missed. Markings can be worn. A pilot can make one wrong turn, and suddenly they are somewhere they do not recognize, still moving, still trying to follow instructions, still believing they are on the correct route. And the most dangerous part is that, on the ground, a mistake can feel normal. In the air, alarms are dramatic. The aircraft behaves differently. The situation announces itself. On the ground, you can be wrong and still feel routine, right up until the moment you hear, "Stop! Stop! Stop!" or you see landing lights rushing toward you. To understand how runway incursions change rules, we need to talk about a crash that did exactly that. Not the most famous one, but one that exposed how a small surface mistake can snowball into a catastrophe. October 8, 2001, Milan-Linate Airport, Italy. That morning, the airport was wrapped in dense fog. Visibility was extremely low, the kind of fog where distance is measured in meters, not landmarks. A small business jet, a Cessna Citation, was taxiing out. In normal conditions, it would be straightforward. In this fog, it became a navigation problem. The Cessna was instructed to taxi along a route that would keep it clear of the active runway. But in the fog, the crew became disoriented and turned onto the wrong taxiway. A wrong taxiway that led directly toward the runway. At the same time, a larger passenger aircraft, a McDonnell Douglas MD-87, was cleared for takeoff. This is the nightmare scenario. One aircraft entering a runway it should not be on, and another accelerating into it at high speed. The MD-87 began its takeoff roll. The crew had no way to see what was ahead through the fog. The tower, without effective surface surveillance, also lacked a clear, real-time picture. Seconds later, the MD-87 struck the Cessna. The collision was catastrophic. Debris and damage crippled the MD-87. In the chaos that followed, the aircraft continued forward and struck airport structures. A runway incursion had turned into one of Europe's deadliest ground disasters. The tragedy at Lanai was not just pilot error or bad luck. Investigators pointed to a layered set of failures that made the airport surface environment unsafe and low visibility. Inadequate guidance, confusing or worn signage, the lack of a functioning ground radar system at the time, and procedural weaknesses that allowed disorientation to become fatal. And this is the key lesson of runway incursion disasters. The incursion itself is often the final move in a long chain. The real cause is the system that allowed the incursion to become possible. After Lanai, the aviation world doubled down on surface safety. Airports reviewed low-visibility operations. Ground surveillance and alerting became a priority. Better markings, clearer signage, and robust stop-bar policies moved from nice to have to you will do this if you want to operate safely. Because the surface environment is not forgiving. It does not care if you are off by one taxiway. It does not care if you misunderstood one instruction. On a runway, close enough is not a concept. Now, if you want the single most dramatic example of a runway disaster that changed international rules, you eventually land on one name: Tenerife, March 27, 1977. 2 Boeing 747s, heavy fog, no ground radar. A crowded airport operating beyond its normal capacity. A sequence of miscommunications, assumptions, and overlapping radio calls ended with a collision that remains the deadliest accident in aviation history. And what Tenerife changed wasn't just procedures at one airport. It changed how the entire world speaks on the radio. After Tenerife, aviation authorities pushed harder for standardized phraseology and disciplined redbacks. The word takeoff became restricted. It is not supposed to be casually used in conversation. It is supposed to be used only when a takeoff clearance is actually being issued, or when canceling that clearance. Everything else becomes departure. The reason is simple: one misunderstood word at the wrong time can be fatal. Tenerife also reinforced another lesson that runway incursions still teach today. In low visibility, the tower is not all-seeing. People imagine air traffic control as a god's-eye view of the airport. In reality, controllers rely on information. Without surface surveillance, fog can blind the tower as effectively as it blinds the cockpit. And even with radar, you still have another problem: humans. Controllers are working multiple frequencies, multiple aircraft, multiple priorities. Pilots are multitasking in the cockpit. Ground crews are operating vehicles near active runways. Everyone is trained. Everyone is professional. And yet the surface environment is where small errors cluster. Misheard clearances. Missed hold short instructions. Wrong runway entry. Assumed permissions. Follow that aircraft confusion. Taxi instructions given quickly to avoid delays. Pressure to keep traffic moving. This is why runway safety is such a stubborn problem. It is not one big failure. It is 1,000 tiny ones waiting for the right alignment. So why does it feel like more people die on the ground than in the air? The more accurate truth is this: the riskiest phases of flight are concentrated near the ground. Takeoff and landing compress workload, traffic density, and time pressure into a short window where the margin for error is small. In cruise, if something goes wrong, you often have time to troubleshoot, divert, and stabilize. You are separated from other aircraft by altitude and miles of airspace. You can request priority. You can slow down. You can hold. You can plan. On the runway, events happen fast, and the separation is measured in seconds. And runway collisions have a unique ability to cause mass casualties because they can involve fully loaded passenger aircraft, full fuel, and direct high-energy impact, followed by fire. Add the fact that airports contain buildings, vehicles, and people nearby, and a surface crash can cause casualties beyond the aircraft themselves. The industry knows this. That is why runway incursions are tracked and categorized by severity. Most are minor, but the rare serious ones are treated like flashing red warning signs. In fact, one reason runway incursions get so much attention in recent years is that aviation has become so good at preventing mid-air collisions and cruise phase disasters that the remaining risk is increasingly concentrated in complex environments like airport surfaces. In other words, the sky got safer, the ground stayed complicated. So what has changed, and what is changing now? First, technology. Airports in many countries now use surface surveillance systems that detect traffic on runways and taxiways and can trigger alerts. There are systems designed specifically to warn pilots when it is unsafe to enter, cross, or take off from a runway. One example is Runway Status Lights, an automated system that uses surveillance data to illuminate lights that tell pilots in plain visual language, "Do not go." It does not rely on a controller noticing a conflict at the perfect moment. It does not rely on a pilot catching a radio call through static. It's a last line of defense. designed for the exact scenarios where humans are overloaded. Second, procedures. Standard phraseology, disciplined readbacks, and strict rules around hold short and runway entry have become a core part of training. Low visibility operations often come with tighter restrictions, fewer simultaneous movements, stop bars enforced, more spacing, and extra verification steps. Third, cockpit tools. Modern aircraft increasingly have airport moving maps showing taxi position relative to the airport layout. That does not eliminate mistakes, but it reduces the lost in fog problem by giving crews a digital sense of where they are. But technology does not replace discipline. Because runway incursions are often not caused by a lack of equipment, they are caused by assumptions. The most dangerous sentence on an airport surface is not a warning. It is, "I thought we were cleared." This is why surface safety culture is obsessed with one idea. If you are not 100% sure, you stop. You stop the aircraft. You ask for clarification, you request progressive taxi instructions, you confirm runway assignments. You verify signage and markings. You do not just keep rolling because you don't want to sound inexperienced on the radio. The runway does not reward confidence, it rewards certainty. And the tragedies that changed rules, from Tenerife to Lanite, are reminders written in the harshest ink possible. The system must be designed so that one small mistake does not become unrecoverable. Because in the air, pilots can sometimes recover from the unexpected. On the ground, especially on a runway, there is often nothing to recover with. Only seconds, only closing speed, only the final realization that the most dangerous part of flight isn't always the sky. Sometimes, it's the pavement beneath you.